Good morning or afternoon, whatever the case may be for you. You should have picked up a blue sheet when you walked in today that says triangle proofs at the top. That's what we're going to be focusing on. As you can recall, yesterday we learned something that you can see on the agenda as CPCTC, which stands for... Okay, maybe. If you said corresponding parts of congruent triangles are congruent, then give yourself a little pat on the back because you would be absolutely correct. What we're really going to do today is kind of press on and just practice more proofs. So we're going to have 3 examples throughout the class today that will help you process through your proofs. Alright? So if at any point you would like to pause the video and try it on your own, that would be absolutely fine. Or if you would like to watch the video, then process through, however you're going to work, that's great. Just make sure that you're not simply writing it all down and going through the motions. This is a very important topic that I want you to learn at your own pace, and that we all need to practice because, well, let's face it, every time I walk into class, or you walk into class, somebody says, proofs. We got to get out of that mindset. Proofs are not meant to be difficult. Also, throughout the day, if I tell you to pause the video, you don't have to do that, but I highly recommend it because it means it's time for you to practice and to do something on your own. Alright, so we're going to hit the ground running with example number 1. And what's the first thing we should do? Yes, you notice in my proof that I've already got 2 statements in here. Where did those 2 statements come from? That is absolutely correct. They are the givens. So I'm going to mark one given at a time. Starting with AB, let's get a different color here, maybe a blue. Starting with AB is congruent to CD. And now we talked about with triangle proofs that when I have marked something, I should also say what it was. So was this an angle or a side? Yes, absolutely, that was a side. So next to both of those tick marks, I'm going to make an S. The next thing, absolutely, I can already see some of y'all are getting ahead of me, is that we want to do the given again. But it's the second given, so we can check the first one off our list, and now we're going to work on the second given. Alright, now the second given says AD, so we haven't marked that yet, and since we haven't, I'm going to mark 2 tick marks since it's a different part of our proof. And CB should be congruent, and I also need to mark what those are. They are absolutely sides. But something we haven't really done yet is identify what we're working with. We're out of givens, and we know that today we're talking about triangle proofs, but right now I kind of see this parallelogram shape or a tilted square or rectangle. So an easy way, if we're unsure of what our triangles are, if you don't see the breakdown, is to sometimes look at your proof. So we know that the proof should be the last part of our proof. And it actually, in this case, tells me what my triangles are. So I'm going to grab 2 colors here. I'm going to do a green, and I'm going to do that A, B, C, A to B, B to C, C to A. So there's one triangle. And then I've got triangle CDA, CDA. Alright, so there's my second triangle. And when I identify those triangles, it should explode in my head that there was an overlap, that they shared this AC. So in my proof, I can actually write that AC is congruent to AC. Because of course, you are who you are. Your height doesn't change simply because you walked from one side of the room to the other or because we shifted you around. So it's still going to be congruent to itself. And what do we call that property when something is congruent to itself? Absolutely. If you said the reflexive property, particularly of congruence, since we are talking about sides, the congruent symbol, we will say POC, and we'll mark on our picture one last symbol. And so now we can look. What is in our picture? Have we created a type of property that would allow us to say that these triangles are without a doubt congruent? Yes, side, side, side. And we can remember that from the song that we learned last week. I believe it goes a little something like SSS, SAS, NASA is okay. SAA is still okay, but no donkeys or batteries. That's absolutely right. That song, although you don't have to memorize it, is meant to help you. So if that's helpful, please tap your toes, sing it in your head, do whatever you have to do to remember the important information. What I would like to do now is have you look at example number 2, and I'm going to set a timer for 1 minute. That's probably not enough time for you to completely finish this, but I just want you to have time to get started and read it. And if you can get through it, great. If you would like more time than the 1 minute, simply pause the video. When the timer's up, you'll hear the duck sound. Okay, guys, you really should be working, not just sitting there waiting on the time to pass or moving the timer at the bottom so that you can get through it faster. Really try it. Don't give up now. You're so close. There it is. It's amazing how long a minute can feel when you're just watching a video. So if you did fast forward, I completely understand, but hopefully you were able to get a good majority of the proof done, specifically because we all know that we should start with our givens. So I'm going to start with this angle, but something that we talked about in the last example was even looking at the proof. Because our proof wants us to show these two triangles are congruent. So in this case, although I could start with the givens, and we will in less than 30 seconds, I do want to go ahead and mark my two triangles. And I'm going to do that the same way. I'm going to take a green highlighter for JKN, JKN, so that's this triangle. And I'm going to take my blue highlighter for MKL. Alright, so we've got two triangles now that we're going to identify this angle. Now the key thing that we tend to struggle with about angles is where to find it. The letter in the middle, so for J and K, it would be this N, and for MLK, it would be this L, is known as what? Okay, hopefully you said vertex, and so it has to be in the middle. And order does matter when trying to prove congruence. So the N is in the middle, and we've gone J, N, K. So we're referring to this angle, and MLK, so we're referring to this angle. And the reason order matters is because of those corresponding parts. Alright, so angle N corresponds to angle L. Yeah, absolutely. Alright, so now you're professional. So we've done that, we've marked our picture, and we go on to the next statement, which I'm going to make just a little smaller so it fits in my proof. And again, it was given, but this time it's kind of weird. It's a statement. It says K is the midpoint of JM. Well, I'm going to identify K. Here's K. What does it mean that K is the midpoint? Yeah, it means it cuts JM in half. Now, specifically, when we cut JM in half at K, it means that each piece must be equal. So we now know that JK, segment JK, is congruent to KM. Now, I did a minute ago say that order does matter. Since we know what we're trying to prove, technically we know that J corresponds to M. So you could also write JK is congruent to MK. And the reason for that is definition of midpoint. Alright, easy peasy lemon squeezy. Not meant to be difficult. Also, something we haven't done yet is actually identify what each piece was. So the first given was a angle. And now our second given was a side. Okay? And so, wait, we're out of givens. We have used this given, and we have used this given. What do we see in this picture that can help us? Yes. Now I want you to think about that. What I've heard some of you say is vertical angles, and you are absolutely correct. If you don't remember, vertical angles are two angles that meet at the same vertex but go in opposite directions, or basically they create opposite V's. So in our case, we could say that angle JKN, angle JKN is congruent to angle MKL. Yes, and that is because of the vertical angles theorem. Now, I've marked everything properly on my picture, but I'm only going to focus on the green triangle. Alright, the reason I'm only going to focus on the green triangle is just to get a more accurate relationship and make sure I don't miss anything. So when I look at this picture, I see right off the bat that there is an A squished in the middle. So I can go up or I can go down. And I can see that I have angle, angle, side, which is definitely a property we allow, or I could see that I have side, angle, angle, both of which will work every time. So that is my final reason. Angle, angle, side. Alright? Woo! You did it! Now, if you're not comfortable with that, this is a good time to pause the video, watch that again, ask a neighbor, call me over, and make sure you understand where we got all of those pieces of information. The last thing we're going to look at as far as proofs is this example number 3. And what I'd like for you to do is actually, again, pause the video and try and complete it on your own. Noticing two things. Our proof is no longer a triangle congruence. So identifying the triangle could be more difficult, and so we definitely want to start with our givens. Alright, so I'm going to set you up that much. Go ahead and see what you can say. Would you just pause the video? Thank you. Alright, so moving right along. Hopefully you did try to fill this in. If not, I'm going to only fill in the givens for just a moment and give you a little more time to try it on your own. And while I'm filling in the givens, I'm actually going to go ahead and mark them. So I'm going to start with WX is congruent to YZ. And WXZ is congruent to WZX. Now, one thing I didn't do was actually identify what those are, so that's your responsibility. What are WX and YZ? Yes, they are sides. So we have sides. And what are WXZ and YZX? Yes, they are angles. So that identification of the angle also helps us identify the triangles we're working with. So if I start with WXZ, I can easily see that we're working with this triangle. And if I do YZX, I have that triangle. And a big red flag should have gone off in your head when you saw these two segments, those lines, well, sides, I should say, they're not lines. Those sides overlap. Those sides have to be congruent because they are the same. The length of those sides did not change. So we can absolutely say that ZX is congruent to ZX. And because you're so brilliant, we know that that is the reflexive property of congruence. And as I've already mentioned, it was a side, so we now have an S here. But this is a lot to look at. So something that I like to do again is cover up what I'm not needing right now. So use your hand and cover the screen where the blue is. Alright, one way that you can physically do that is if I, let's see, get a dark marker. I don't recommend you do this to your paper. And I'm actually just going to cover it up for you. Alright, so if I cover that up for you, what's squished in the middle? An angle, and it is squished by two sides. So absolutely, we have an angle squished by two sides. So we know that these triangles are congruent. And I'm actually going to cheat and take my given and just make the angles into triangles. Ha ha ha, look how cool I am. So yeah, those two triangles are absolutely congruent. And because the triangles are congruent, we know that corresponding parts of congruent triangles are congruent. Yay! You should feel so good. This stuff is not meant to be difficult. It's just a mindset change. We made sure to use both of our givens, to put the proven at the end, and to go step by step. Alright? You have got this. One last thing we're going to look at today is this table here. And I'm actually just going to fill it in rather quickly, probably in less than 5 minutes. And so if you want, between each of the different rows that I talk about, you may want to pause the video and try it yourself. Alright, so we're going to start with number 1. And the conclusion is that the triangles are congruent, meaning that I need to use side, 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 angle, angle, side, angle, side, angle, angle. I've got to have one of those properties. And I notice that these two triangles share a side. So very quickly, I know that this is side, side, side. Now again, I'm moving through this fast. So if you didn't see that, feel free to pause the video, raise your hand, call me over. This next one says that the triangle is right. Now it specifies that it is right, so I'm going to draw my box where it looks convenient. Because there is a right angle, and our reason is definition of a triangle, all we have to say is triangle RST is a right triangle. Alright, so that one really gave it away on its own. If there's a right angle, it's a right triangle. Easy peasy, lemon squeezy. Now this one's a little different. What do you notice on this statement, on this picture? Okay, you notice we got the angles marked, and then what is the reason? Triangle sum theorem. Well, you should know that A plus B plus C equals absolutely 180 degrees. So see, that wasn't terrible. Then we go to the fourth one. Now the fourth one's also a little different because it says that each of these angles is less than 90 degrees. So what type of triangle must that create? Yes, it must create an acute triangle. So all you would say here, the reason, you could say all angles are less than 90 degrees. Alright, and I'm sorry that that's ugly, but put a smile next to it and it makes it happier. The last one, number 5, tells you that you have one angle. This particular angle is greater than 90. One angle is greater than 90 degrees, so it must be obtuse. And again, ugly handwriting. Yay, smile, makes it all better. Alright, so that is it. That is it for today. You should have a fun little activity in front of you. It asks you, how does a witch tell time? And then there's one proof on the back and another table like this to complete. You guys are absolute rock stars. You can do this. Raise your hand, get help, and remember that I'm always here if you need me. Tweet me, whatever it takes, you've got this. Talk to you later. See you on the flip side.